Alright, well here is a quick overview, a very quick overview of Chapter 8. We're going to talk about a couple different things. We're going to talk about factoring. Sorry, not factoring. We're going to talk about radicals, roots and radicals. So here we go. I got roots and radicals. Roots, radicals. For the most part, we're going to talk about radicals. We're going to talk about the square roots. So if I'm looking for something like square root of 8, and I'm going to simplify that. What I have to do is I have to find something that I can rewrite 8 as. So my perfect squares are 1. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36, etc. And we're going to look for one of those. We're going to look to rewrite a number in terms of these. So if I got square root of 8, I'm going to look to rewrite square root of 8 as square root of 4 times 2, because 8 is 4 times 2, and then 8 gets, each of these separate factors gets its own house. Square root of 4 gets its own house, square root of 2 gets its own house, for the reason that square root of 4 can become 2. There's 2, square root of 2, and I'm done. I've pretty much simplified that square root of 8 to that 2 square root of 2. So if I've got a number, I always look to rewrite 8 in terms of a perfect square, 4 or 9 or 16. Alright, we've got a different situation if we've got square root of, for example, square root of x, x to the 9th power. If I've got a variable, what I look to do is rewrite that variable in terms of, again, a perfect square. What would be a perfect square? Since perfect squares are even, or have even powers, if you're talking about variables like an x, you rewrite it as in terms of the highest even numbered power that can go into the power that you've got. So we've got x to the 9th. We can rewrite it as x to the 8th times x to the 1st power, because x to the 8th times x to the 1st is x to the 8 plus 1 is x to the 9. So we've just rewritten x to the 9th, and that's all we've done. Now we can rewrite this as x to the 8th, square root of x to the 8th, square root of x, x to the 1st is just square root of x. And now we've got x to the 8th is a perfect square. So now if we're looking for a perfect square out of x to the 8th, divide that 8 by 2, and we get square root of x to the 4th is our base of a perfect square. Because remember, when we've got parentheses around a base, you multiply the inside exponent by the outside exponent to get our product, to get our product's exponent. So 4 times 2 gives us 8, and the nice thing about this is x to the 4th is a perfect square now. X to the 4th squared is a perfect square inside of square root. Don't forget we've got to write our square root of x down now. And now the base of that perfect square, x to the 4th, gets to come out of the house. Gets to go, if you take the square root of a perfect square, the base comes out of the house. So this is x to the 4th times square root of x. And we're done. Because you can't simplify square root of x any further. X to the 4th is now out of the house, as you say, or out of the square root symbol, and we're done. We've simplified it as much as we can. The reason behind that is if we take, for example, square root of 25. Here's an example of, taking a look at a number. Why do we take the base out of a perfect square? If we look at square root of 25, square root of 25 is 5. And if we take a look at square root of 25, we can write it as square root of 5 squared. And therefore the base gets to come out of the house, 5, just like our answer there. Square root of 25 is 5, and if we rewrite it as in terms of a base squared, we get 5 squared is 5. Right, and the square root of 5 squared is the base coming out of the house is 5. Just like over here, we got x to the 4th comes out of the house, x to the 4th. And now, what do we do if we've got, well, for example, other possibilities would be square root of 8 x to the 9th power. In the blue, is it any different from what's over here in the green and the red? Not really, because all we have to do is rewrite this square root of 8x to the 9th as square root of 8 square root of x to the 9th. And now we can simply take a look at square root of 8, simplify this way, square root of x to the 9th, simplify this way, and we get square root of 8 is 2 square root of 2. Square root of x to the 9th we've done over here, x to the 8th times x to the 1st, x to the 8th gets its own house, and we get down here, we've got x to the 4th, square root of x, and now all we have to do is pay attention to what's outside the house, and what's inside the house, multiplied by, remember all this stuff is multiplied together. So this would be 2 times x to the 4th, and if we make it pretty, we'd say here's the 2 and the x to the 4th that are outside the house. We put them in front of the square root. And now what's inside the square root? Square root of 2 times square root of x is square root of 2x. Just like here, we could take 8 and separate it into 4 times 2. We can also take 4 times 2 and combine it into 8. Here, we're taking square root of 2 times square root of x, and we're combining it to get square root of 2x. Now the last option, I guess, is to say, well, what if we get something outside the house? Negative 5 times square root of 8x to the 9th. Don't get so concerned about this, because all we're doing now is seeing what we can separate and conquer. I've got negative 5 times square root of 8 times square root of x to the 9th. And all this over here, we've simplified right here as 2x to the 4th square root of 2x. And this negative 5, by the way, all this stuff is multiplied by negative 5. So now we just make it prettier. Negative 5 times 2 is negative 10 x to the 4th square root of 2x. So all you have to do really is remember that in the green, if we've got something like a number that says square root of 8, we just separate it into 4 times 2. Square root of 4 gets its own house. Square root of 2 gets its own house. And square root of 4, we know, is a perfect square, so square root of 4 just becomes 2. Square root of 2 does not simplify, and there's our answer. Same thing with x to the 9th, or any variables, really. X to the 9th, you give 8x to the 8th its own power, and x to the 1st its own power, because x to the 8th is a perfect square. So if I'm going to suggest studying anything, I would suggest studying this, x to the 9th, x to the 15th, y to the any power, and just all you do is when you see a variable like this to a power and you're taking the square root of it, find the highest even power, and we're looking again for square roots. If we're looking for square roots, you find the highest even power that goes into x to the 9th, or whatever you start with. X to the 8th happens to be here because x to the 8th is a perfect square because 8 is even, and therefore you can rewrite it as x to the 4th squared. Then the base gets to come out of the house. Whatever is left over is just left over. So there's the bottom line of chapter 8, roots and radicals.